It's good to be here. Yesterday I was getting ready to travel to Tulsa. I had a talk on earthquakes, as usual. So I'm glad to be here and talking about something else that's closer to my heart. But I was explaining to my daughter, she said, "Why do you always have to go places to give these talks?" And I said, "Well, I'm important and people want to hear what I have to say."
How old's your daughter?
But yeah, I was going to follow up with, she's 11 now, so that's not good enough for her. And she said, "Why don't they just call you?" So I've been racking my brain for the last day and a half to try to think of ways that I could be more animated when I speak so that you actually have to see me and I have to be present to give these talks. I haven't come up with anything, so. And I think it's maybe fitting that I'm the last speaker here because the Oklahoma story, in terms of the High Plains Aquifer and how water is managed and regulated, is much simpler than all of the others. I think we have the least regulation in terms of water permitting, and we don't have groundwater conservation districts, groundwater management areas. How many districts do you have within the High Plains Aquifer? About 20. So we're the simplest case of all. When I was invited, we were given the task of talking about the general geology and the trends that you see in the aquifer in your region, and then talk about the regulatory controls and the state laws governing groundwater in the High Plains Aquifer. So starting with some of the figures you've seen already, and I have to apologize here, I think my references are not always current, but nonetheless, you see the geologic framework here. This is the base of the aquifer in Texas and Oklahoma. And so our groundwater region in Oklahoma encompasses the Panhandle region. There's 3 counties there, and we have about 5 counties that touch the High Plains Aquifer in this part of western Oklahoma. And the base of the aquifer is important for understanding the saturated thickness that's available for pumping. So as we monitor groundwater levels over time, we will look at the change in that saturated thickness. And in Oklahoma, that's an important consideration because we basically will manage and regulate the volume of water that we can pump and permit for pumping based on the available saturated thickness. So the base of the aquifer in Oklahoma's highest point is out here in the Panhandle, so the base of the aquifer actually increases in elevation, as does the ground surface to the west. So if you look at the saturated thickness, this next slide, you see that it varies from tens of feet in Oklahoma in yellow to 400 to 600 feet in green. So it's relatively thin, in some areas very, very thin, and we have a few places in the Panhandle where the aquifer is not present. There's no saturated thickness. So in Oklahoma, the Oklahoma Water Resources Board is the regulatory authority for setting the rules and issuing permits for groundwater production and or surface water use. And it is a legal property tied to the ownership of the land. So if you own 1,000 acres, you are issued a permit based on a certain number of acre feet per acre that you own per year. And so you have to prove a few things to obtain a groundwater permit, that you will put the water to beneficial use. That's one important piece here, and waste of the water would not occur. So what I typically do when I investigate an area in any state, including Oklahoma, is try to start with a kind of a water budget. And so I have a table that I'll build out throughout this talk, starting with, of course, how much water is in storage in the Oklahoma portion of the High Plains Aquifer. So that's the first line there, A. We have about 90 million acre feet, according to the Oklahoma Comprehensive Water Plan that was published in 2012. And the date of the volume there, the groundwater storage, is in question. I'm not sure that it was actually that volume in 2012. But nonetheless, that's the amount of water we have to deal with. And because we regulate the water as a non-sustainable resource, we're basically planning to use that water over a 20-year period of time. The maximum annual yield, the MAY, is based on issuing permits to use that water in a 20-year time frame. So each landowner will get an equal proportionate share. That's their share of the maximum annual yield that they can take advantage of. And that actually is capped at 2 acre-feet per acre per year. So any landowner can potentially extract up to 2 acre-feet per acre per year from their land. And it might be scaled downward depending on the sensitivity of the aquifer to climatic conditions and its general trend. So the High Plains Aquifer in Oklahoma has about 4 million acres of land, and the recharge rate is very, very small. It's estimated in that OWRB Comprehensive Water Plan and the final order that was established for most recently for our MAY, our maximum annual yield, to be less than 1 inch per year. And so if you do the math there, you get an acre-feet per year rate of 244,000. Very small amount of recharge. So in Oklahoma, we do a study of the aquifer about every 10 years, develop a maximum annual yield, divide up the water within that aquifer to maintain it for 20 years, giving the equal proportionate share to the landowners. So in Oklahoma, the most recent MAY was official in March of 2002. So I'm interested in if we are planning to use this water over the next 20 years, where do we stand now in 2016? So that was my approach here, is to try to look at water permits and water use and then water decline and see how they all match up. And if that water budget kind of plays out, we can learn something about the potential lifespan of the High Plains Aquifer beyond 2022, I guess would be the planned lifespan. So this chart at the bottom shows the number of wells that were permitted by county. As I said, we have 7 counties that touch the High Plains Aquifer. The Cimarron, Texas, and Beaver County in the Panhandle are the biggest users of water. They have the most wells, and everything's bigger in Texas. So in Texas County, we have by far the most wells in the Panhandle. And you can see those wells that are permitted are shown in blue, and just a satellite image in the background. And then I also have 2 background colors here. This is the equal proportionate share for the Panhandle. That was issued at 2 acre-feet per acre per year. So if you own land in the Panhandle, you can pump 2 acre-feet per acre that you own. But in the western part of the state, the other 5 counties, if you own land, your equal proportionate share is only 1.4 acre-feet per acre per year. That's a mouthful. And I think that has a lot to do with the saturated thickness. The aquifer is thinner here, and the recharge rate potentially is lower there. And the current status is, it's actually probably better in this part of the state. So you can see Texas County, the most wells, second most Cimarron County, Beaver County, and then Ellis County has the most wells in the western part of the state. So fortunately, all of those permitted wells are not pumping at their permitted rates. Otherwise, we would be depleting the aquifer much faster. This is the rates of the permits as they've developed over time, and I'm going to mention here that I'm missing data in the 1930s and 40s. There certainly were permits issued back then, and water was being pumped, but this is what we have record of. Again, everything's bigger in Texas, so that big green wedge is the permitted pumpage from Texas. as it's developed over time. And so today, in 2016, we have issued permits for 6 million acre feet per year. And so I'm adding that to my stat sheet, among other things. This is where we left off last time. This is the Panhandle, these 3 rows here, 2 acre feet per acre per year. This is the area of the Panhandle, and this is what I would calculate as the maximum annual yield for the Panhandle region. My numbers might not match the OWRB's numbers perfectly because I just did the calculation with my GIS rather than referring back to the final order. But nonetheless, they're in the same ballpark. So about 6 million acre feet per year can be permitted in that Panhandle region. And the northwestern part has a lower equal proportionate share, a smaller area, and a smaller total permitted, allowable permitted amount. So if I looked at the permitted withdrawals in 2002 when that May was issued, we had about 4.5 million acre feet per year of issued permits. And in 2016, that's crept up to over 6 million acre feet per year. But like I said, we aren't using water at the same rate that it's permitted, fortunately. I think Jim Butler mentioned this earlier, that we don't always have a good handle on how much water we're using, and certainly in Oklahoma we do not. This data set that I'm showing here, the red bars are the estimated High Plains aquifer water use from the USGS reports. They generally have a 5-year report of water use, estimated water use. And so you can see our estimated water use peaked out about 700,000 acre feet in 1995, and it looks like it's declining. I've estimated water use in 1985 and 2010 because we don't have reports in those years. So it looks like our water use is dropping off. Most of the water use certainly is for agriculture, as you see from this pie chart here at the bottom. And then I'm investigating recharge. I had a little project in Ellis County, and they wanted to understand the sustainability of water in that county. So I ran this little recharge model called WHAT, and basically estimated base flow as a proxy for recharge. So you can see the red is base flow, which means almost all of the creek flow or stream flow in this area is driven by groundwater. And so to get to the trends, this is a pre-development to 2000 trend. These are probably not the correct publications, and this certainly is not either, but this is similar to the diagram that I think Jim Butler showed earlier for a well in Oklahoma in Texas County. And that is prior to any of my own investigations into the High Plains Aquifer of Oklahoma. That's the trend that I thought in the back of my mind was occurring everywhere. But you can see in the western part, over in Ellis County, it's actually going up, or it's holding steady. There's essentially no change there. Most of the decline is certainly in the Panhandle and Texas County. And so, as the only hydrogeologist in the state of Oklahoma, I often have to do a quick and dirty look at what the trends are in different aquifers. So this was my first attempt to do that. I looked for data on NWIS to look at the longest term trends that I could find for the High Plains Aquifer, and this is the one that I could find. It goes back to 1956. And you can see all of these wells are primarily up here in the Panhandle, and they are all declining pretty steadily. Now, when I did a more focused study in Ellis County in these wells here, I found that most of those were holding steady, not really declining so much. So I was validating some of this data. And what I've found is the average water level decline aquifer wide is about 10 feet over this 14-year time frame. So adding some more things to my table here, and I'm going to wrap it up in the next slide. I estimated the recharge rate using that WHAT model and looking at base flow, and I think the recharge rate is much lower than even 0.7 inches per year. I think it's 0.08 inches per year in that region. And that would mean the recharge rate aquifer-wide would be even smaller. And what I see in the change of storage, if I map it out, I get about 4 million acre feet decrease in storage from 2002 to 2016, which is pretty close to our permitted withdrawals in 2002 and consistent in a sense with the declines that we saw in this time frame. So things are making sense. This is kind of just the wrap-up slide that shows the change in water levels in Oklahoma from 2002 to 2016. I used about 87 wells to run this just the other day. There's roughly 200 that are accessible from NWIS that I could incorporate here. But the declines, the largest declines are obviously in Texas County and down here in Cimarron. I'm going to blame this one on Texas. I think they're doing something here. We need to investigate further. But we do have some areas where we have very little decline or actually an increase in water levels over time. And I'll wrap it up there. Thank you.